Hi, today we're going to talk about solving systems of equations using substitution. So the word substitution just means something is in place, we're going to take it away and put something else in that place. Okay, so just like a substitute, substitution is the same idea. So let's say you have a question that says, solve the system of equations. And maybe the system of equations is 3x plus 5y equals 10, and 2y equals, let's see, 2x plus 6, something like that. Okay. Well, you have multiple options for how you could solve this. You could solve each equation for y, then graph both of those equations if you have a graph. Wherever the two lines cross, that point is the solution to the system of equations. So that's your one strategy. Another strategy is you could solve both equations for y, then set the two equations equal to each other, and then solve. That'll give you the answer for x. Plug it back in to solve for y. And then the third option is what we're going to do today, and that is only solve one of the equations. So in this case, I'm going to solve for y. Now, I could have actually solved for x if I wanted to. The task is, or the goal or the idea behind substitution is, find the easier equation and solve for the easier variable. So in this case, it's easier to get y by itself. But if it had been easier to get x by itself, that's what we would have done instead. So I need to get y by itself. I'm just solving an equation. Divide by 2 on both sides. And y equals, we'll have to do 2 divided by 2. That is 1. 1 times x is just x. Plus, I have to do 6 divided by 2. Well, 6 divided by 2 is 3. So now I have solved this. Now, this actually tells us, this statement right here says y equals x plus 3. That means y is the exact same thing as x plus 3. They're the exact same thing. Doesn't matter which you use. So we're going to take that fact and use it in the top equation. Right here where it says a y, we're going to say, hey, guess what? Y is the exact same thing as x plus 3. So we're going to get rid of the y, and we're going to substitute in x plus 3. And let me show you what I mean. I start over here. I have 2x plus 5 times. Now it's not times y anymore. It's times x plus 3. I cannot just write times x plus 3 because order of operations would tell me to multiply the 5 times just the x. But because y is the exact same thing as the x plus 3, all of it together, then 5 has to be multiplied by all of that. So I'm going to put parentheses around it. And then that equals 10. Well, now this is just a multi-step equation we can solve. Draw my wall. 2x, I'm not going to do anything with that yet. Plus, I'm going to distribute 5x plus 15 equals 10. Now I can combine some like terms. 2x plus 5x is 7x plus 15 equals 10. Now it's just a two-step equation. Subtract 15 on both sides. These are gone, and now I have 7x equals negative 5. Divide by 7 on both sides. And x equals the fraction. See how this, it is negative 5 divided by 7. Well, it's also a fraction. Negative 5 over 7. So that's our answer for the x value. Now you'll notice that it is a fraction. This is one of the great things about substitution. If we had tried to graph this, then our two lines would have crossed at a fraction, and we would not have known exactly what the answer was. But with substitution, we were able to see exactly that this was 5 over 7. So we're not done, though, because with systems of equations, we have to have an answer for x and an answer for y. Well, we have this handy-dandy equation right here that says y equals x plus 3. So all I have to do to solve for y is, hey, I know what x is. X is negative 5 over 7 plus 3, right? So all I did, this is like substituting again, right? I got rid of the x, and in its place, I put a negative 5 over 7, and I'm just going to use the calculator. Negative 5 over 7 plus 3, that equals 2 and 2/7. So our final answer is we do x comma y, negative 5 over 7, comma 2 and 2/7. So substitution, this was so great because we ended up with fractions. This one would have been a lot more difficult if we were trying to graph it. So that is substitution.